I'm John Rowland with Highland Park Lapidary, and right now we are machining the 16 machine Vise bases. The first operation is facing the top of it. We put some locating notches in here and drill and tap these holes. So that's what we got running right now. This is the first operation where we're facing it. We're taking off about 76 thousandths of an inch, which is a pretty healthy cut, but we're not pushing it too fast because we want a real nice surface finish on this so that Vise is sitting perfectly flat on it.
Talk a little bit about the grade of aluminum we're using.
This is A356 aluminum, which is basically a pretty good grade of cast aluminum. It's strong and has good wear characteristics. And it's fairly easy to machine too. It's a little tougher than some of them, but it's not quite as gummy as like a 6061. So we're almost done facing, and then we're going to come in and do the contour cuts on the edges, which takes the part to length. So when we pick it over to our next operation, all we got to do is the sides and the bores.
And that tool there, that was a Sandvik tool?
Yep. Now we're grabbing our end mill for the contour cuts on the sides. We're just taking the part to length here. Doesn't waste any time taking that material off. And now we're going to put our locating notches in it. This just makes the next operation real easy to keep everything perfectly aligned. Now we're going to spot drill for our tapped holes, and we're using the spot to actually countersink so we don't have to come back with a secondary countersinking operation. We use a little bit bigger spot drill to do that and sink it a little deeper. Now we're going to drill the holes before tapping. Got it cranked up so we can really take the material out fast using carbide. And then our last step is the tapped hole. We're tapping here at about 1200 RPMs, but we're using the German taps and they are awesome. And there you go, that part is done on this operation. Now, if you look here, when we finish the part, this is our jig for when we do the second operation of this part, where we're going to take the part and turn it this way. So when we put these notches in here and then take this part and set it down on the jig, and get fumble fingers to stop messing up, and then basically it sits down here and is perfectly located.
And so that'll be a fourth axis procedure for doing cross bores.
Yep. Right now we're finishing up the machining on the Model 16 Vise base. We're doing the bores, we're doing the center for the feed nut. We've done the top deck and the tapped hole. So this operation is doing the bottom side.
So tell them what we're doing in each step.
Well, this is spot drilling. You can't really see the part here because we're tilted up onto the front side. It's going to flip it here and you'll see the spots from that. We're going to spot drill the back side. What the spot drill does is it allows the drill bit to come down and very quickly be perfectly centered, because if it's not, it's more likely to break. Because we're drilling on both sides, and if you're using carbide or cobalt, it's just a better idea to have a spot drill. If you got a stubby carbide drill, you can get away with it, but we have to be out a little because our tooling is so close to the trunnion that we don't want to have the spindle run into our trunnion.
Why don't you tell them what a trunnion is?
The trunnion is this orange thing here. Basically what we do is we connect it to the rotary indexer, which is the red box there on the right. The indexer is a precision rotary device, can move the table on any angle, so we can do perfect 90s, you know, from horizontal up to one side or the other. And of course that ensures that we have our bores perfectly aligned, and it also means on a part like this that you don't have to do 3 setups, you can do it all in one setup, because we do the right side bores and then rotate it over here. Now we're going to drill the left side bores, and that makes these bores perfectly aligned. So that was our clearance drill there, big carbide clearance drill. Now we're going to grab a bigger drill to punch out the hole in the center part where the feed screw, cross feed screw goes through. You can see we're pretty close to our table on that one. We don't want to run into the table because that could get expensive. This side we got a little bit more room because of the offset. Now we're going to drill the screw that holds that cross feed nut, just for the screw hole here. Now we're going to do our center slot next. And the center slot's kind of important because that slot width, if you don't control it, if it's sloppy, then it means you got a lot of backlash in your cross feed.
And why does that matter?
Well, if you got backlash in your cross feed, then either you're going to have a hard time maintaining the same slab thickness, or you'll get the cross feed kind of moving back and forth as you're cutting. You'll get lines in the side of your slab.
So blade.
Now this move here, we're going to take the part to width. So the casting is cast a little oversized. We just come down and hog that off the sides. Now this casting is a little thicker than I'd like to see it, because we're taking about 80 thousandths off each side. Doing the far side now, and then the last step will be doing the bores. Now we're going to rough our backside bores.
Talk about how important this is in terms of the saw performance as well, the bores.
Well, when you're looking at bore tolerances, which is one of the problems if you look at the history of lapidary saws, the saws that were considered really great saws always did a better job of having more precise bores on them. It makes them a little bit more expensive to make because you've got to have some decent equipment when you're boring them, and they have to be aligned, because if they're not aligned, then you'll get binding. Now, what some manufacturers have done is that they'll open up the tolerance on the bores to get away from the binding. But if you hold tolerance on these bores, then you can have a really smooth, really precise cross feed with no binding. But it means you have to be serious about doing the machining right.
Or some people only use one cross feed, one rail as opposed to two.
Yeah. If you got two rails, those bores have got to be perfect. Otherwise, they won't go together. Now we're roughing the front side, and we're going to finish the front side, and then this part's done. So finish on the middle bore. The last two bores here now, and then this part will be done. And that finishes the run on this, 100 pieces.
Hey, thanks for watching today. If you like what you see, click the like button. Subscribe if you want to get more videos like this. And down below in the description, you'll find a link that goes to our website. It goes to also what we showed you today, more information about that. And leave comments. If there's things that you like, if there's things that you want us to do more on, if there's videos that you want us to shoot that we haven't shot, we're very open to that. We're really looking for ways to help you be successful in your endeavors with the tools and technologies that we create, as well as any other aspect of the hobby.